Hey guys, welcome back to the fourth tutorial on our series in developing a banking application with Microsoft Orleans using the Active framework. In this video, we're going to talk a little bit more about state persistence and grain persistence. So we're going to take, say, the balance that we had in the previous video that we just stored in memory in a variable, and we're going to use the Orleans grains persistence to store that persistently. We're going to look at the flexibility that Orleans gives us in configuring many different grain providers that use different types of underlying storage like Cosmos DB, even Amazon AWS DynamoDB, and different ones of them that are supported. This is going to lead into future videos where we start to look at, say, streaming, transactions, and different things like that, more advanced topics in Orleans. If you're enjoying the video series, don't forget to subscribe to the channel and click the notification bell to be updated on the latest videos in this tutorial on Microsoft Orleans. Orleans provides a very flexible grain persistence model, which allows us to set up grain persistence in a way that suits the specific needs of our application. Grain persistence is achieved by configuring many different grain storage providers, which are backed by different storage technologies. Some of these providers are provided by the Orleans team, while others are provided by the community. In our example, let's say we have two grain types, an ATM grain and a bank account grain, similar to what we created in the previous video. We might then configure several different storage providers. For example, we might configure two storage providers to be backed by Azure Cosmos DB, while a third is backed by AWS DynamoDB. We can then use any of these providers to store our grain data depending on our data requirements, which might require us to store certain grain data with certain providers or in certain regions or with certain latency, replication, or persistence guarantees. Orleans allows us to use the same data provider as the grain storage mechanism for multiple grains. Additionally, we can store multiple state objects for a single grain across a number of different configured storage providers. In our example, the ATM grain is using the DynamoDB storage provider to store its detail state, while its balance state is being stored in the second Cosmos DB provider. We might have made this decision because in our case, the balance state needs to have super low latency, and we have already configured our Cosmos DB data to be replicated across multiple regions for quick reads. The bank account grain does something similar, storing some of its data in one storage provider provided by DynamoDB, while another state is stored in a separate storage provider provided by Azure Cosmos DB. Also note how we're using a single storage provider to store part of the state for both our grain types. Orleans provides full flexibility to the developer, and we will see later in the video how to configure storage similar to this. Additionally, grains can also access any external data store without using the grain persistence model directly. This allows calls to databases to fetch additional data. For example, in cases where we need external data to process a call to a grain, but this data should or does not live or belong inherently to the grain itself. In our example, we might have an external data store that is backed by a database such as MySQL or SQL Server, Redis, or really anything. Our bank account grain is then able to make external calls to this method during grain activation, say by overriding on activate async, or during the processing of any grain messages. Okay, so now we're back in Visual Studio, and let's add some state to the checking account grain that we added in a previous video. So the first thing we'll do is just add a new folder to store all of our state classes. And our checking account grain is going to have two different states that are associated with it. The first is going to be called balance state. Let's create an object to store the balance state. And the second is just going to be the checking account details. So we'll add a new class and just call it checking account state. And these two classes are what we're going to store the data that is persistent as part of our grain state. So the balance state will be pretty simple. We'll just make it a public record. And we're just going to have one property here. So we're going to just store the balance as a decimal. And we'll add a getter and a setter for that. And two things that are important to note here is we need to make sure that this is serializable by Orleans. So we'll add a generate serializer annotation to the class. And we'll also add the ID of 0 here, just to make sure that this serializes correctly. I've got the best outcomes when adding generate serializer and ID. I've also had trouble when I use an init only setter here, so probably best to just use a getter and a setter. Let's delete our usings that we're not using, and let's go over to the checking account state and also add the generate serializer annotation to that and make it a public record. We might want to add just some generic details here. So we might just add the account ID as part of the grain state. Add a getter and a setter again. We might also want to store, say, when the account was opened. So opened at UTC. And we might also just want to say what type of account it is. So we'll just store that as a string for now. Simple account type. Enum would also be appropriate here. And obviously we want to make sure that these serialize correctly. So let's add ID 0, ID 1, and ID 2. And we can delete the unused usings. And that's basically all we need to do to just create our two state objects that we're going to then use inside our grains. Okay, so now that we've added our state objects, the next thing we might want to do is configure the storage providers in our silo. So to do that, we basically want to edit this use Orleans lambda here. And first things we'll do is install a NuGet package to give us access to the Azure storage persistence. So we simply want to search for Orleans persistence. I spelled that wrong. So we can see here, Microsoft Orleans persistence Azure storage is what we want because we want to use our persistence backed by Azure. You can also see other ones with ADO, memory, DynamoDB, Redis, etc. that we can use, Cosmos DB. So once that's installed, we can go back to our program. So what we do is we do silo builder, add Azure table grain storage, and inside here, we give the name of the storage provider that we want to configure. So we'll just call this table storage. And then we want to give some options. And again, inside here is basically where we just configure some options. And the main option in here is really just the connection string. We can copy it from use Azure storage clustering because we're going to use the same storage account, the development storage account. And that's essentially our Azure table grain storage configured. And we might want to add a second storage provider here. So we can add different things like Cosmos DB, DynamoDB. We just need to make sure we install the appropriate packages like we did for Azure storage. In our case, we're just going to use the blob storage, which is also part of the package we've already installed. So if we do silo builder again and add Azure blob grain storage, we'll just call this one blob storage. And in configure options, we will configure it in a very similar manner. So options, blob service client, and it will be new blob service client with the same connection string as the table because the blobs and the table both use the Azurite storage that we've already installed and we're running locally. So that's essentially the main thing we need to configure here. We can also configure a default storage provider. So as we'll see later when we're configuring our grains, if we don't specify a specific provider to use, Orleans will default to the default provider that we provide. So if we go silo builder and something like add Azure table grain storage as default, and we simply provide the options here rather than a name. So if we don't specify a name, as we'll see when we're actually using the storage providers in our grains, we will default to this table storage client. So we probably don't need to use the default grain storage here, the default table grain storage. We're just going to use the explicit table storage and blob storage we've added here. So we're just going to comment that out for now. And before we do anything, let's go ahead and add a couple of methods to our grain iChecking account interface. So this will allow us to increase or decrease the balance in our grain and save that persistently. So let's just add a simple debit and amount here, and the same for credit. Simple credit method. And once we've added them, we can go back to our checking account grain and we can implement those methods. We'll leave them not implemented for now, but the first thing we'll do is add a constructor. And here is where we want to basically inject the state provider that we want to use through dependency injection into our grain so that we can use it in our methods. And to do that, we simply go persistent state. We give the type of the state we want to use. So for this one, balance state, and we'll call that variable balance state for now. And then we want to annotate that with the state name and the provider name we want to use. So persistent state, and then the state name will just be something like balance, and the storage name or provider name will be what we set up earlier. So if we want to use table storage for balance, we'll simply copy table storage here. If we left this part out, it would simply revert to our default storage provider. We haven't configured a default storage provider here, so we should definitely use the explicitly named storage provider name. So that's our balance state, and we want to do something similar for our checking account state. So we'll simply copy this. We will use blob storage for this one, so we'll just call it blob storage instead of table storage. And obviously we need to change the state name from balance to checking account. And we need to change the type again to checking account state. So now that we've injected both of them, let's add some private read-only variables to store them. So private read-only persistent state. It's going to be balance state and balance state. And we'll do the exact same thing for the checking account state just here. So checking account state and checking account state. And then in our constructor, we'll set the private variable balance state into the injected balance state and the checking account state into the checking account state. So nothing really radically different here from normal dependency injection. The main thing is just to make sure you have the correct state object and storage provider name that you use, and you're using the obviously the classes that we added to store our state as well. And we can also, I guess, get rid of this balance here, and then we can update these two here in a minute to actually use the balance state that we've added. Reading the balance state is super easy. So we just want to use this persistent state interface here. So we say balance state, and then we say state, and then all we simply do is access the balance property on that, and that will then return the balance. The interesting thing here is that this is actually not, you don't need to await this. This is because the state has already been loaded when the grain activates. So by the time the get balance method is called, the grain is already active. We already have kind of synchronous access to the state. We don't need to wait for it to be loaded. And then we also want to obviously write the balance as well. So on initialize, this balance object is no longer here. So what we want to do is we want to set the balance state. So we can simply go balance state balance is equal to opening balance. And then we actually want to save this, and we do need to await that call. So we say await, and we go to balance state, and we just say write the state async. And that's it. That's as simple as it is to write and read our state. So let's do the same thing in our debit and our credit methods, but actually change rather than set the balance state. So first thing we'll do is just read the current balance. And we will say the current balance again as before is balance state balance. And then for credit, we want to increase it. So we'll say new balance is equal to current balance plus the amount. And then we want to set that again. So we want to set the new state the same way we did here. But instead of using opening balance, we obviously want to use the new balance. And we want to make this async. And that's the whole thing. So read the current balance, create a new variable for new balance. You could do this inline, obviously, if you wanted to. Set the state and then save it. So let's do the same for our debit method. But in this case, we're going to decrease the amount. And again, we need to make that method async. Easy. So that's essentially our entire checking account grain setup to use the state providers and store the balance persistently on the grain. We might also want to initialize our checking account state, say in the initialize method. So we can do that for two states in the one method. I want to say something like state open.ucc is equal to datetime UTC now, and also say checking account state account type. And we'll just set it to default in the grain for now, and also checking account state account ID is equal to this get grain ID get GUID key, so that will be the grain ID as well. And then obviously we're storing the balance state and we're saving that, but we're not saving this one, so we also need to save that. So checking account state, write state async, and that will write all of the checking account state here. I'm not going to add a method for now to actually read the checking account state. We might in the future, but for now, we'll just initialize it and save it alongside our balance. Obviously, if this was a real system, we'd want to have some checks around this to make sure the balance doesn't go negative if there's an overdraft, or maybe some better exception handling and different things like that. But for a very simple system, this is how you would implement it to begin with. Okay, so let's jump across to our client, and we actually want to now call these new debit and credit methods that we've added. And we don't actually need to make huge amount of changes in our client because that's not interacting with Orleans directly. It's just doing it through a client that calls a silo, and that interacts with the persistence we've added. So we don't need to add any new packages or anything in a client. That all happens completely abstracted away from it. But what we do want to add is we want to add some new post methods to allow us to change the balance. So let's start by adding some new contracts that we will use in our post methods. So we'll just add one for credit and one for debit as well. And these will simply be public records. They'll be serializable using data contract and data member. And they'll have one single method, one single property each called amount, which is in it only, and credit will be very similar to this. Obviously, it will just be called credit. Instead, we could use the same contract for both of them, but just to be a little bit more explicit, I'm going to use a different one. And then we want to add the HTTP methods that actually use these debit and credit contracts, and then call the debit and credit methods on the grain we just added. So let's copy the checking account one we already have, because we'll be doing something pretty similar. The method will need to take the checking account ID we want to use as a root parameter, and we will call this one debit. We will need to access the checking account ID in it, and we will, instead of using the create account contract, we'll use the debit contract we just added. We'll call that debit. We still want to inject the cluster client because we still want to proxy to our silo. We don't need this anymore because the checking account ID is passed in the method. We've added too many C's in the checking account ID, which is fine. So we don't want to initialize anymore. We want a debit, and the debit needs to be passed the amount, which is on the debit contract. So debit dot amount. And instead of doing created, we will do typed results dot content. And we want to do something very similar for debit as well. So let's just copy this post, create a new one, and change from debit to credit. We want to use, we want to use credit here as well. Credit on amount, and obviously the credit method rather than the debit method. So that's it really for adding our new API calls on our client. I think that's everything we need to do to make this work persistently. So we can fire it up now. We might have again missed a couple of things, but we will call the posts for debit and credit, initialize and get balance, and see are we actually setting and persisting our balances correctly. Okay, so let's start our cluster and make some API calls to the debit, credit, get balance, and initialize methods, and check if we are persisting our state correctly. So let's click start our cluster. Obviously, we want to make sure that we're both starting the client and the silo the same way we saw in the previous video. So I'm going to open up Postman here, which I have already added my API calls, but they're just the same as the ones we add in ASP.NET. So initialize and get checking balance from the previous video, and I've added new ones for debit and credit, which again are just the same. And I apologize for the small text here. I couldn't make the URL text any larger, but it's the host, port, checking account, the root parameter of our grain ID, and then debit or credit. So let's start by initializing a new account with €1,000 balance or $1,000, whatever your currency of choice is. That succeeded. Let's get the ID from the response header. Let's check the balance on that by copying the ID into the root parameter and then doing /balance. We should get 1,000 back. Perfect. So let's then try to debit the account by €10 and see what happens there. That seems to have succeeded. 204, no content, no exceptions. So we will look to get the balance again. It's gone down to $9.90 as expected. And let's try a big credit of $100 or euro. Again, 204, no content, which is great. And we would expect to get €1,090 here. So that's great. Everything looks to be working as expected. But for the real test, let's stop our cluster, which should clear any in-memory state, restart it, and make sure we're still getting the €1,090 response back as our current balance. So we'll just stop it in Visual Studio, give it a second and restart. Wait for it to start up correctly. And what we'll do is jump back into Postman and make the same request again. And we get the same balance here, just with the decimal point, which is just fine. So that's basically it for grain persistence. I guess the most important thing to remember is that all the states are loaded on activation. So all that state should be available to you on any of your grain calls. And obviously, as we discussed at the start of the video, if in say that debit or credit methods that we've added on the grain, when we're processing the message that triggers them, if we want to make an external call to a database to, I don't know, get some risk information or something completely different, we're able to do that as well. We just do that as we would really in any other database call. We just do an await, get risk data, pass some information, get them back, and that's fine. And that's exactly how we would do it. So thanks for watching this video on grain persistence. In the next video, we're going to take a little bit of a deeper look into grain communication. So how one grain communicates to another grain, and that will lead us on to other topics in the future, like streaming and transactions and different things like that, that we will also cover in this series. So again, thanks for watching. If you're enjoying this tutorial series on Microsoft Orleans and you want to see it more of it, or you want to see other topics in distributed computing and distributed application development, don't forget to subscribe to the channel and hit the notification bell, as well as liking the video if you feel like you got something from it. Thanks again.